Hey guys, so in this video we're going to talk about the unit circle in trigonometric functions. Now what exactly is the unit circle? The unit circle is defined as a circle with radius 1 unit and center point 0, 0. In other words, the center point of the unit circle is the origin. So over here we have the unit circle that has center point 0, 0 and a radius of 1 unit. Now let's say that the angle theta can be defined as the angle subtended from the positive x-axis. So now let's say that I take the radius from the positive x-axis, which is to the right side of the origin, and I subtend this radius by an angle of theta. Now this angle is said to be positive or is said to have a value of greater than 0 if it's subtended in the anticlockwise direction or the counterclockwise direction. So in this particular example that I've shown, whatever the value of theta, it must be a positive value because I've subtended in the counterclockwise direction. On the other hand, had I made it in the clockwise direction, then I would say that theta has a negative value, or that its value is less than 0. Now, the question is, wherever the radius, once I subtend this radius by an angle of theta, we want to be able to express the x and y coordinates. In terms of the angle theta that we subtend the radius by. So how do I express the x and the y coordinates in terms of theta? Well, we can say for the unit circle, or for any circle rather, that the ratio between the x coordinate and the radius can be expressed as a cosine of theta. And since the radius is just 1, we can just say that the x coordinate is the cosine of theta. Similarly, the ratio between the y coordinate and the radius can be expressed as sine of theta. And since the radius again is just 1, we can say that the y coordinate of any point in the unit circle in terms of theta can be expressed as sine of theta. Another way to visualize this is that we know that the x coordinate of this point, is the horizontal distance from the origin to this point. The x coordinate of this point is the horizontal distance from the origin to this point, whereas the y coordinate is the vertical distance from the origin to this point. So we can visualize this in terms of a right angle triangle. For this right angle triangle, we can say that the base of the right angle triangle is the horizontal distance, which is the x coordinate from the origin to the point, and the y coordinate of this right angle triangle is the vertical distance from the origin to this point over here. So then we can say, from our previous understanding of right angle triangles, we know that the sine of theta is just the side opposite the angle theta divided by the hypotenuse, which is just the radius here, which is 1. So sine of theta is equal to y over 1. So we can say that the y coordinate is just equal to sine of theta. And we can say that the x coordinate is the side adjacent to this angle theta divided by the hypotenuse, which is just x over 1, which is equal to cosine theta. So we can say that x is equal to cosine of theta. And lastly, we know that the ratio between the side opposite and adjacent to the angle theta, in other words, the ratio between the y and the x coordinate of any point on the unit circle, can be expressed as the sine of theta divided by the cosine of theta, which is equal to the tan of theta. So over here what we have is we have the three basic trigonometric functions, where the x coordinate of any point in terms of the angle theta subtended from the positive x-axis can be expressed as the cosine of theta. The y coordinate can be expressed as sine of theta, and the ratio between the y coordinate and the x coordinate can be expressed as tan of theta. Another thing that we notice over here is that if we look at this triangle over here, using Pythagoras' theorem, we can say that x squared plus y squared is equal to 1 squared. So we can say over here that x squared plus y squared is equal to 1 squared. And since we know that x over here is just the cosine of theta, since x, the side adjacent to theta, divided by 1, so adjacent over hypotenuse, which is just x over 1, is equal to cosine of theta. So we can say that cosine of theta, the whole thing squared, plus the sine of theta, the whole thing squared, since sine of theta is just y over 1, so we can say that this is equal to 1. And the cosine of theta, the whole thing squared, can be written as cosine squared of theta plus sine squared of theta is equal to 1. And this gives us one of the trigonometric identities that we'll be using over the course of this entire syllabus for trigonometry. And the second trigonometric identity that we derived was that the tan of theta is equal to the sine of theta divided by the cosine of theta. And these are the two trigonometric identities that we'll be using over this math course.